Yeah, so the Darwin, the Evolution Special will air on February 10th at 7:30 p.m. on KQED. And there are tune-in cards by the cash register. So this particular segment that you're watching, or about to watch, is from our half-hour special called Science Under the Microscope, about the state of science instruction in the Bay Area. And we feature a couple of really great, fabulous teachers in here, one of whom is Stanley Richards, who's a teacher at the City Arts and Tech High School, which is a charter school. And when I was working on this episode, what amazed me was that the kids, it's not that the kids don't get science, the kids are extremely bright, they have a lot of enthusiasm for learning about science, provided that it's presented to them in a participatory, completely immersive way. So I applaud all of you teachers here tonight who do that day in and day out. And without further ado, I think we'll just start the segment. Thank you.
This is very exciting. Yes. It's like Christmas when you get new packages of materials and things.
Third grade teacher Joyce Craig is preparing the science laboratory for her incoming class at Henry Haight Elementary School in the city of Alameda.
We'll be looking at the geology of the Earth, and that's why we're starting with our rocks.
On the first day of science class, her lab is ready to go.
Science journals, something to write with, and then over to science lab.
Okay, put it in the center of your table. Okay.
It's going to be your job to look carefully at these rocks and to observe them and to see what they're about and write a small description about the rock.
It turned into dust.
Oh my gosh, why?
Because I'm making little rocks together.
Do you think I think the most exciting thing in teaching science is just watching the kids go, whoa, look at that. And just that excitement that they get, it just energizes you.
Joyce Craig's new science lab is the only one in her district's 9 elementary schools, and it took her 20 years to get a room large enough to hold it. Her students now get about 5 hours of science instruction each week, and they're very lucky. A 2007 survey found that 80% of Bay Area elementary school teachers spent less than 1 hour a week teaching science. That's half the national average. And the report, compiled by the University of California, Berkeley's Lawrence Hall of Science, had other bad news.
The report is pretty shocking because it says that so little time is being spent on science in Bay Area classrooms that teachers feel woefully underprepared to do what we're asking them to do in the classroom, that they get little to no support, and that districts and the school system aren't adequately either staffed or funded to do anything about it.
California's science education problems have been shaped by historical forces, which have created a public education system that spends roughly $8,000 per pupil each year. That's less than the national average. The state's low per-pupil spending was an unintended consequence of a civil rights court case called Serrano versus Priest. In the 1970s, the California Supreme Court ruled that funding public education through local property taxes was unconstitutional because it created unequally funded school districts. To comply with the ruling, the state legislature essentially lumped property taxes into one centralized pool and redistributed them equally.
When you equalize spending between high and low spending districts, you have two choices. You can bring the bottom spending districts up close to the top. That's what the people who brought the lawsuit envisioned, that everybody would be spending near Palo Alto and Beverly Hills. The other way to solve this equalization problem is you bring the top down to the middle and you bring the bottom up somewhat.
You ready? Follow Miss Rosman.
As it turned out, in response to rising home values, voters capped property taxes by passing Proposition 13 in 1978. As a result, the state ended up with significantly less money to spread around.
So we equalized down, and in that way we led to what I have called equalized mediocrity. Class sizes increased, the length of the school day was cut down, the number of teachers for special programs was cut. Laboratories for science were cut. We had essentially cut everything we could without eliminating all the basic classroom teachers.
Can you hold
As
up
we've
the block
seen,
and
some
read
public
what
school
I'm
science
talking
teachers
about?
do get their students excited about science using sheer strength of will. But what if schools made science education even more immersive, more hands-on? That's what City Arts and Technology High School in San Francisco is doing. The charter school's curriculum is designed around project-based learning concepts. The idea is to integrate science with math, English, social studies, and other subjects by combining them in broad projects. For many students, this makes the relationship between science and the real world much less abstract.
Mental process, all right? Which is the next step.
I hated science, and I didn't want anything to do with it, and because it just was never accessible to me. I didn't understand how labs related to the book or what the text meant, and I know some friends from other schools still hate science because of that same reason. It's just a book to them. But when I came here, it all just started to make sense. Like, it all comes together, and it actually got me excited about science.
So I want you to get those three.
The students are still held to rigorous academic standards, taking tests and writing papers. But at its base, this is not about learning strictly from a book, but about a new level of engagement.
Then you work on.
It's about, the way you learn it. Like, I learned science from a book, and it wasn't interesting, and I learned the same things from an excited teacher with tools and a lab, and that changed it. That was when I realized that this is really cool. This is fun.
One project last year was an assignment called Bill Nye and I.
The Bill Nye and I project, first and foremost, was designed so that students would produce a kind of a high-quality, college-level scientific research paper.
But this was no ordinary paper. The students needed to produce a short educational video as part of a scientific lesson plan they created for younger elementary school students.
One group created a character called Captain Labcoat, and she had a pirate hat on and a white lab coat and this hokey backdrop and with an eye patch, and she kind of jumps in front of the camera and starts sort of delivering something that she knew an 8-year-old was going to love. If their parents were the audience, there's no way they would have kind of let down their guard. But when you have them look the other direction, generationally, so to speak, all of a sudden they're being held to the standard of care for those who come after.
It's equal to about 1.618.
By involving teamwork, creativity, script making, video, teaching lessons, science becomes a form of communicating and interacting with the world.
And the school is getting results. 44% of the students scored proficient or above in the state science test. That's 4 points above the state average. And 95% of the graduates enroll in 2- or 4-year colleges. But there is always resistance to change.
There's often questions about whether the work that we're doing is replicable into the broader public school system. In fact, we believe that our practices and what we do can be a model for public schools everywhere. And we set out to show that this same practices can get great results for traditionally underserved students in urban environments. So when I talk to teachers about what we're doing, we talk a lot about, the transforming of the lives, which is huge. And drives me, every day to get up and try to make a difference.
What do you think of the state of science education here in California? Does anyone here have any children? You do? Are they in school? What do you think of the state of science education here in California?
I think it's kind of a mixed bag. I mean, my son goes to school with a great science program. My mom teaches at an elementary school where she doesn't get to do really any science because she has to do English and math and things that are on the test. So I think it depends. It's different for
kids have different experience.
And what age range does your mother teach?
She teaches 3rd grade. My son's in 3rd grade.
Okay. Who else has an experience with how science is treated here in the state, whether it be in schools or just how education is treated?
Well, I actually moved here 2 years ago, and I was hired as a science specialist for K-5 because the head of the school knew that it's overwhelming for elementary teachers. They have so much on their plate to have to be trained in science, and maths, and the growth, and all that stuff too is too much. And so my director made a commitment that was important to him.
But that's a unique case.
It is unique, yes.
It's Berkeley. So that's the case for unique. So I really want to hear, what are your impressions of what science education is here in the state?
I'm involved in evaluating school programs for science, and what we're seeing here in San Francisco and in the East Bay is that there's actually less time for teachers now to teach science because of standardized testing requirements. So there's actually all these very innovative experiments that we're seeing. There's not as much time to teach, especially in the elementary school. And where we're seeing the most impact in terms of improving scientific knowledge and literacy is in informal science settings, after school, before school, in non-traditional classroom settings. And I think that that really needs to be encouraged from K through 12, actually.
A non-traditional setting such as a bar, maybe a Monday night around 8 p.m. So I'm curious, does anyone disagree? Does anyone think that the state of education, science education here in California is on the right track? No. Boo science education in California. No one's a big proponent of it.
I spent the day at Cal Academy of Sciences and at the aquarium, which is so crowded with people, and so I can say I felt really lucky to live in a city that has that as a resource and has so many people that want to get in there that you can hardly see the exhibits. So I do feel like some things are being done right.
That's great. You seem to indicate that the populace is behind science education. What about that money figure? What was the number? $8,000 per kid? Is that right? Is that was in the piece? What is that sound like a right number? Is there somebody here that's familiar with budgetary situations for schools?
In the suburbs of Chicago, it's up to $15,000 per kid.
In the suburbs of Chicago,
like the higher end suburbs or the socioeconomic, like higher suburbs where they do depend on property taxes locally, they can spend up to $15,000 per kid.
So let me ask the. Oh, go ahead.
I was going to say, as a counterpoint to that, in I think the District of Columbia, I just moved from DC in September, but they spend $12,000 or $13,000 per student, and that's in the city, which is very poor education, just generally. So money isn't everything. It's also the system, individual systems themselves, the motivation of the directors, the principals, and whatnot.
So let's ask. So we've had 3 speakers tonight. We're losing one. How about we ask the high school teacher? Do you think money is the solution to science education?
Well, if you don't have the tools to do experiments in the lab, then you're probably not going to do any experiments. Although you can see that the things I have set up here tonight are not particularly expensive. It's still more than $0, and so if you don't have the equipment to do the work, you're not very likely to. You don't need thousands of dollars, but you need some money to be able to do it. You need people who are teachers who are interested in doing it as well.
Is that a problem in your experience, finding teachers that are interested in doing it?
Yeah, because they feel unprepared. A lot of people who are in science don't have very much experience doing lots of sort of high school level demonstrations and experiments, and so they feel they don't do them. They just like stand up and read parts of the book and try to look knowledgeable in front of their class.
Do we have a few teachers here tonight? If you're a teacher? Oh wow, there's actually a surprising few teachers. Do you agree with that? That teachers are underprepared and in some cases unwilling?
Well, I teach elementary school, and I'm actually a science teacher in an elementary school nearby. And I mean, elementary school teachers have to teach all the subjects, of course. So even if they're prepared, it's like finding time to prep for science is really difficult. But I wanted to say that 4 years ago, when I came to teach for San Francisco Unified, I was told that by administrators that I didn't really have to worry about teaching science. It was really important to teach math and literacy. But now, 4 years later, the 5th grade test scores have come out, and it's really clear that the fifth graders have totally bombed science, so now there's a lot more emphasis and funding priority for science, which is kind of sad and ironic, but good also.
And remind us again, how do we know that fifth graders just don't know anything about science right now?
They failed the standardized test, which may or may not tell you something.
Well, what kind of stuff is on a standardized test for a fifth grader?
It's pretty sophisticated, actually. The state test it's pretty complicated, and it's earth science and physical science and life science all together. And I mean, I have trouble taking some of the
Yeah, I was just going to ask, how do you think we do?
Probably not very well, and a lot of the questions aren't well written. I mean, the testing, people don't do a great job writing the test, so it's not that clear, in my opinion.
So I'm going to ask a sort of a solution. I'm going to gear towards solutions. Like, there is this feeling that there is a problem. How do we address it going forward?
I think a huge part of it is the interest in science and the excitement that the parents have, and the exposure to science from a young age. That's why all these outside activities that are shown. Well, who's taking the kids to the extracurricular science activities? It's parents who are excited about science. So I feel like that's where a lot of the thrust should be, to get parents excited.
Are you excited about science?
Totally. Yeah. Why do you think I'm here?
Do you have kids?
Yes, I do.
Where are they?
One of them is one of Zeke's little chickadees, and the other one goes to a public high school in Pacifica.
And do you agree with what's been said about how science education is treated in these schools? That it's...
Which part? I mean, I thought what was portrayed in this little video clip was a lot of hogwash. In that, by parading around this, 44% of the kids scored proficient. Well, what did the rest of the kids at that school score? Below basic? Far below basic? That's what I'd like to know. I mean, how many of them scored advanced? How many of them really understand? How many of them just had fun? Because the kid that's in the public high school in Pacifica has gone through most of her life doing project-based learning, quote unquote. And I don't see much meat to it. I don't. Not a lot of meat. That's me. Sorry if some other people will not agree with me, but I think project-based learning done well is amazing, but I'm not so convinced that what's being done in the public schools and is being called project-based learning is truly effective.
So I'll come to you right now, but I'd like for some of the speakers who do project-based learning to think about what she just said and react to it in a second.
I went to California public schools, like high school in the late 90s, and looking back, I think we had really awesome classes. I went to school in the South Bay. We had fantastic experiments in our classes, and I think it was the teachers who were really excited about the work that they did that made us do things that actually related to what we wanted to know about. I remember we soaked a Twinkie in water to see how spongeable it was, and things like that, like made ice cream in chemistry class. So things that can be related to what you do in real life, I think, is what kids need to see, because that's what makes them motivated. But I think in the past 10 years, it has gotten worse because of all the standardized tests and everything that people have taken classes now.
Who kind of disagrees with that the standardized tests have sort of kind of cast a pall upon how we treat science education? Hey, look, a science teacher thinks that way. But I'm going to ask my wife first.
Well, hi. This kind of leads into, well, I was wondering, because a few people were saying, oh, they can't teach science well because of the standardized test, but I know science is on the standardized test, so I don't understand the link, and I thought someone could explain it to me.
So when you have standardized tests, of course, the first desire for teachers is to teach to the test. I actually have no problem with that if it's a good test. Like, if it's a great test, it's great to teach towards it. The pilot's exam, for example, is a really good test, and it's a good thing that they teach pilots to do well on the test. But when you can go online and see examples of the questions that are on the California science exam for the different grades. And every time they release questions, I'm always amazed because some of the questions have more than one right answer, or no right answers, or the answers are so wrong they're not even wrong anymore. And so if you have a bad test, then it still can differentiate students, but it makes it then trying to teach to that test doesn't then educate students. So I don't think standardized testing is intrinsically a bad plan, but you have to spend the money to get a good test, and then you can have good standardized testing.
Well, not exactly a standardized test, but one thing I noticed, the longer I've been doing this for 18 years now with this science workshop, and sometimes I say, I feel it's only this year I've really learned to teach science, because I've kind of it's taken me that long to get the confidence to actually let the kids just do a bunch of observations. But what has gotten in the way a lot of times is that they want to start throwing words at what they see because they think that's what I want as a teacher. Because some of them I know, some of their teachers who are my best friends, I know the way they teach them is that they're worried about the exam, so they're saying they need to know these words which are often meaningless, such as carbon dioxide, oxygen, well, you know, the whole. And so right away they'll start saying, I'll ask, well, what are you seeing? And they'll say, carbon dioxide. They're like fishing for these words. I think, no. And we have to go through this thing, like I'm saying, pretend you were just born yesterday, or we just arrived from Mars. You don't know any science words. You don't even know what science is. All you know is what your eyes tell you. What are you seeing? You know what I mean? You have to get down. It's like Zen. It's like some kind of beginner's mind. I mean, and that's what I see is it was an obstacle for me to teach these kids when they see a piece of ice floating in water, you know, a piece of solid water floating in liquid water, to tell me exactly what they're watching and not to start saying why. Because right away they think, well, that's what the exams, they want you to say, why does this happen? Why does this happen? And then you bring in all of those words, and it's all this thing, you know, it's kind of a brainwashing where, you know, I went through this, we all did this, went through this. Didn't everybody here go this, when you were in school, is that a lot of what's going on is you're trying to figure out what the teacher wants you to say because you want to please the teacher. And so I go through this whole time with this. This is not about making me happy. I do not want you to say what you think I want to hear. And a lot of them, they will not get over that because you keep hearing this. They're like trying to psych you out and figure, what does he want us to say? Or what does our teacher want us to say? So they're going to be happy and pleased and pat us on the head or give us whatever points. You know what I mean? So this is an obstacle to doing what Darwin did, Michael Faraday did, Ernest Rutherford did, all of these people who were able to, admittedly much older, to simply look at the world in very close to a completely unprejudiced way and gather all this incredible data that led to these amazing theories and all.
You want to make a quick comment?
Well, one thing I've always noticed about science is a lot of times science is taught as a sort of, you know, weird parlor trick or something. It's never really applied to things that people use in their later life. And, you know, things like how to analyze for PCBs, you know, by using a piece of copper wire and a flame and using bits of plastic to see if it makes the flame green or not, depending on if the stuff has any. But something they use later on in life to analyze, particularly if you ever try to look at, you know, how do you analyze your environment? Your environment is, and your health and what kind of nutrition is in your food is very, very important. If you can,
let's see if people agree with that.
It makes science more useful to you. You know, I think there should be an emphasis towards useful science as opposed to a series of cheap parlor tricks.
Does anyone think that the science they learn in high school, elementary, is useful science? Okay. Oh, I passed you right on.
I don't know if I'm going to answer this directly, but I teach my kids at home, and I found something to use for chemistry last year, for like a middle school intro to chemistry, and it started with like talking about how, well, the first exercise we did was go through the kitchen cupboards and see how many things had flour, baking soda, sugar,
so like, two things.
Analyzing recipes, you know, and But then asking, well, if you're using basically the same things, why do you wind up with different things? Then it moved from there into having you look at your toothpaste, your medicine, and finding a list of basic elements and talking about how the universe is made up of these basic elements. And I did well in high school chemistry, but that was the first time that I ever went, oh, there's elements in my toothpaste. Like that, really grounding it to earth. And I found it so fascinating. And I've been rediscovering a lot of things about science by working with my kids on these things.
So let's find out something. Who knows what's in toothpaste? Fluoride. You're going to be a teacher right now. So fluoride, titanium oxide, carrageenan, which is just in everything now.
Sodium bicarbonate. It's seaweed though.
What's that?
It's seaweed. It's algae.
Yeah. Yeah. So one of those soy byproducts that's in everything. What else? Calcium carbonate. If you have a nice baking soda toothpaste. What?
Sodium lauryl sulfate.
Sodium lauryl sulfate, which we all know and love, because we run across that every day. Sodium lauryl sulfate. But I have a follow-up. What do all these things do? We listed off what's on the side of the toothpaste, but why are they in there?
So sodium lauryl sulfate is what makes it bubble.
Sodium lauryl sulfate makes it bubble.
Yeah.
Oh, I didn't know that. So who said bicarb? Right? You said bicarb.
I think it's helps to
Scouring your teeth. And you said carrageenan.
The carrageenan makes it so it doesn't separate, so that it stays together.
Carrageenan keeps Fluoride helps your teeth stay strong. I feel like I'm in a commercial when you say that. So, as a teacher, what do you think?
Well, I guess partly I came tonight because my kids are getting older, and I'm stuck between all this great explorative stuff that we did when they were younger, and now they're getting to high school age, and I'm going, now what? Like, do I need to just go out and buy the textbook and have them memorize the terms so that they can pass their SATs? Or can we just keep playing? They go to a one-day-a-week class where they're out in the woods all day with people who've got like biology degrees and environmental studies degrees and so on. And they play in the woods all day, and they know so much about birds and medicinal plants and all those things. But as a teacher, I become uncertain about how to prepare them for their next steps.
Okay, I'm going to pick on somebody. Are you a college professor by any chance?
Yes.
Okay, so let's pretend she asked that question to you. And not from a question of tell me what to do, but I actually want you to answer that question from you're that 16-year-old kid that grew up to be the college professor. What ignited you at that age to go forward into the realm of science that you really found useful?
Well, I mean, I guess there's two answers to that question. One is I had really good science teachers. And some of them actually, I was just telling our previous speaker, did the exact same experiment we saw tonight with the bubbling hydrogen gas and blew it up. So, you know, really good teachers really helps. And they had good ways of learning about the elements and so forth. But, you know, the other side of that question is I was always encouraged to observe what I saw, you know, and like you were saying, you know, we look at a piece of ice that's melting, and I think my science teacher told me that there's 90 observations you can make just by looking at a piece of ice melting in water. You know, you can observe the height of the ice, all kinds of things. So that's what your kids can still do in the woods. You know, they can go out and be very observant of things in the woods, and then, you know, if your goal is the kids passing the SAT, maybe there's some things that they'll need to know that, you know.
But we're talking, was your question in the vein of passing the SAT, or what was it in the vein of? What do you want for this?
Well, I think I'm trying to, I mean, on one sense, I want them to just be engaged with the world, and I want them to be interested, and I want them to just keep going in whatever they are made to be and made to do in the world. But then they do want to go to college. There's these practical questions, and our systems don't necessarily lend themselves to just, like, the college admissions people don't sit down with my child and have a conversation with them about what they think about ornithology or whatever they're into.
Frankly, I lead a science discussion every month. I've never had that conversation with anybody.
You can come over and talk to my son.
Well, I guess I would just say that, maybe you need to have your kids learn something to get the SAT, to pass the SATs, but I hope they never lose that spirit of excitement found in nature and found even in a science lab too, because that's an important part of making scientific discoveries. And if you look at the discoveries that John Muir made about geology, he was just walking around herding sheep when he made all those discoveries, but he was able to observe what he saw in nature and get quite a long ways with it.
The only thing I'd like to add to that is that, and you can take it for the self-serving conversation that I'm about to suggest, and that is that the genius scientists were in fact geniuses. Not all of us going out into nature doing the same experiences that John Muir had would have had the same experiences. Not all of us had this. Lots of people had the same exact experiences that Darwin then had, but they didn't make the same conclusions. And it's worth suggesting that the appropriate prompts, the appropriate questions, asking the right questions is usually where the genius science happens. And that as teachers, we already know the science, so part of our job is then to ask students the right questions to help them understand the world around them. And to expect them to just get everything on their own, I think that's expecting probably more than they're capable of. So at some point, I think we need to go beyond just encouraging children to go out in the woods and explore the world. We want that kind of knowledge, but then we also want to help them become directed to be help to see what they're supposed to be observing and what conclusions we'd like them to draw from it.
So Zeke, I'm going to ask you a question. So I see you at science cafes pretty much every month. What is a question that's in your head when you show up to learn more? Like when you go, I saw you last month at a discussion on how paintings are analyzed. When you showed up at that discussion, you walked in not knowing something, I assume.
Yes.
So what did you walk in the context of?
Well, I was really curious what computers, the person was talking about how you can use computers to analyze paintings to get information about them. And I was really interested if there was anything that computers could do to understand anything about artwork. And when he was explaining it, how that worked, for want of a better expression, I just found it really fascinating. I was really curious about how that worked out, and then the way he explained it made it very interesting for me.
I went to that same science cafe and loved it without having any interest in the subject matter initially. And I was going for the same reason that I enjoy science classes now, which is that if the person that's talking about it is really passionate and really excited about what they're talking about, I will find it interesting. And that's what I'm thinking as I'm hearing all of this, is that my teachers that have engaged me with science have really given a shit about what they're talking about. And they really care, and that's what they're trying to communicate. And that's why I went to that science cafe, that's why I'm here tonight, that's why I am going out to these things, is we're able to have engaging discussions whether or not I have any basis of knowledge on this subject matter, because the person that is starting it really, really cares about it and wants to share it.
This is the theme I'm starting to see as well. I love that. It goes back to the point made over here about how we all approach science and imbuing that into our children, because as much as this is a discussion about science education, it's about ourselves. I'm on my soapbox now, if anyone can't see. So I'm really curious about how you approach science right now, how you approach learning in your life now. We're adults, we have problems. The economy is bad. It costs so much to fill my tank. It's all these myriad of things that we're responsible for. But my question now is, how do you approach science in this day and age? And I'm going to take away one thing from you. You got to take away from your answer showing up to this event tonight. How do you kind of be curious about the world? I'm really interested, because this is where my passion lies, is bringing people together that really want to be curious. And that's why I'm standing here in something I've been doing for a few years. So I'm curious, what makes you curious? And how you get your science information.
May I real quick?
Yeah, absolutely.
So you actually said earlier, I'm curious how people interact with learning, or how they have interacted with learning. And I found that kind of interesting because people would still say that you're learning mathematics or learning English or whatever, which seem to be the two-pronged things that are causing all sorts of problems with standardized testing. So you must focus on learning through English and mathematics, but somehow science is unrelated to that. And I want to step back and say maybe it is unrelated because it's a manner of thinking. You do a scientific method, you start to think about and have a different relationship with truth and proof and experience that you can't necessarily find in an English classroom or a mathematics classroom. And even still, like, you can get to a correct answer in math. Like, you do algebra or whatever it is that you're doing, and you have a correct answer, but it's a method. It's not the same as science is, for example, which is like there's an unknown and I have to figure out how it can be known. English is interpretive. So I feel like there are two different prongs that maybe are being focused on unfairly, and science it should be brought back into this limelight as a manner of thinking.
I disagree with one giant thing you said.
Thanks.
And you said that science is a way of figuring something out. I think science is finding the question.
Well, yeah, it's fair enough to say, but I mean, once you have the question, what do you do with it? You don't leave it there. Science would never say,
nothing.
Hey, I found this great idea. Why is stuff falling? Never mind.
No. The way science works, the way science works now is you find the question, then you beg for money because you have this great question. Then you kind of make that question a little smaller, and then you beg for more money.
I went to a technical school, so I had an awful lot of science and physics and everything. And listening to what everybody said, it sort of reminds me of the fact that I had such great difficulty learning things because the way it was taught, we had all these fantastic experiments, fantastic teachers, but all they were gearing to was passing, in my case, O-levels and A-levels to get to university. But did I really understand anything? And the fact of the matter was that I didn't. And it's because everybody, some of these people have been saying, is focused on just getting past the exams and learning all these facts and figures and previous experiments and everything. And I'm glad this light experiment came up because it's absolutely right. The books are all wrong. And it sort of got me tricked out. So I realized how much I don't know. So I think that's my bit.
Yeah, I'd like to sort of combine these. Zeke was saying a minute ago that not everybody is a genius. So not everybody, when presented with really high quality stimuli, will form any conclusions at all, necessarily. My gripe about the project-based learning thing that's going on in so many schools, I guess is, I have a stepdaughter who came home absolutely raving, bubbling over with excitement because they had the best science lesson in the world. They had dissected a squid. It was so cool, it was so cool. I said, okay, well, what did you learn? She couldn't tell me anything. She said, well, there was this thing inside. It looked like a quill. It was so cool. That was it. She spent an hour and apparently the teacher hadn't really impressed upon the students how important it was to actually come away having learned something about the squid.
So what's more important, that she was excited or that she came away with some fact?
I think you have to come away with you need to learn to analyze. You need to learn to if you're not born with an inquiring mind. I think the excitement is necessary to begin wanting to search for. But if you come away and all you've got is just this warm feeling because you had fun for an hour, then what's the point? That's when I say this project-based learning can be done really well, but I don't see it necessarily being done well. That's my gripe.
Can I just ask what you expected her to do with information that she learned about the anatomy of a squid? As opposed to information that she learned about the anatomy of a squid as opposed to being excited about science. I'm wondering how you value one over the other.
What I wanted and hoped for was that she would get excited and want to get on the internet with me and learn something about invertebrates, learn something about, talk about evolution, compare something. Just, I wanted her to go somewhere with it, to come home excited and go somewhere. And I was the only one who got on the internet to find out what the thing that looked like a quill was, but it didn't go anywhere.
Okay.
That's what worried me.
Just what I would say, I'm thinking of at this point is the kids that I deal with, mostly we go up to 10th grade, but mostly it's K to 5, and mostly kids. A lot of them are immigrant, first generation. 90% are probably low income, about 80-85% Latino. Pretty much there aren't any white or well-educated kids that we. I mean, there are less than 1% that we see. What I see is that their experience base is very, very limited. I mean, some of them have never even been to the ocean. Which is, I mean, it sounds crazy, but you know that. And what I see is that, you know, I think the why question is really. I love the why question, and I read and I think about it. But with them, like, I'm really hesitant to start hitting them with the why. Well, why do you see that? It's just to see it. It's the seeing, because they have seen so little, because, you know, their parents don't have the time. They're both working to take them to see stuff, whether it's in nature or the exploratorium or wherever it might be. That just opening up and seeing what the inside of a fish looks like is, for them, it's like, well, it's already a step towards something. You know what I mean? As opposed to, say. And I would agree, you know, if that's all they can do, open it up and say gee whiz, and they never go beyond that. But I think what I see is our main role, my main role at Mission Science Workshop, is to provide, like I said, all this stuff are your teachers. They've never really seen bones before. They've never seen a real human skull, and they've never seen all these things. All of these things that are there, rocks and fossils and all these things. To me, if they really see those and observe them and can draw them and we can talk about them, that it's less important that we get into why or how as opposed to what.
So let me forget about your children for a second. They're not here. So who has an opportunity to kind of play with science like they did tonight outside of something like this? Yeah.
As an adult.
What, as an
adult, you mean?
As an adult. As you, oh, okay, so the science teacher, the college professor, after you finish your grant, what is it that you do? Oh, so you're an engineer? How do you do it?
Oh, I was gonna say baking and cooking.
Baking and cooking.
Like playing with the elements, like you were saying.
Well, that...
And observing our cats.
That takes away that fight. Then you're gonna have to keep baking and cooking.
Evil.
Do you have an opportunity to do it? I heard you say so.
San Francisco is riddled with chances to do... San Francisco is riddled with opportunities to do science as an adult. Huh?
The exploratorium?
So there's the science museums, like the exploratorium, but then there are a ton of sort of amateur science societies around here. There's Dorkbot, which, what a great name that is. There are all the people who are involved with, there's the Crucible, there's the tech shop down on the peninsula, and there are dozens of organizations you can immediately get involved with to do science, as well as great websites so that you can play with stuff in your own home and try to do your own experiments and blow up your driveway and burn down your garage. I mean, all these great things that you can do. Just make sure your insurance is paid up first.
So my commitment, after all this discussion, we've kind of circled around a lot of topics, is to bring that curiosity up to the front of your mind so that you can do with it what you will as an adult, whether that's you imbue it into your children, you go off to Dorkbot. I hope that's fun. It sounds fun. Whether you burn down your garage, I'm going to come to you in a second.
One place that Zeke didn't mention, that's fairly late one, it's called noisebridge.net. It's a little tinkering workshop that's on Wee Street. And it's 83C.
So noisebridge.net is another one.
And it's located on 16th Street, just the first alleyway west of Mission Street.
But back to what I was saying is my commitment to all of you is that we create that together. We find whatever that is. And I'd like to see us actually I know I went to mission science workshops to meet Dan the other day. It feels it's an incredibly personal mess. That's the way I'll describe it. It is a great mess. It is a collection of all these incredible things that are on the shelf, and I'd love it if we could take a group of adults there to play. I don't know if you'd be open to that.
I was going to suggest that.
Oh.
I think everybody should volunteer at Mission Science Workshop.
Hey, volunteer. We want to be the tier. We don't want to vol in. We want to play, I think. So I encourage everyone to find whatever that is inside of them that wants them to be curious, that wants them to go to Dorkbot or Sound Bridge Noise Bridge, or to the tech shop, whatever it is, because that's the place of learning that I think we can really impact everyone with. Because if there's one thing I agree with that was said tonight, and there's more than one, it's that how we approach science is the way that affects everybody else. So I approach science in that I should have a beer with it, and it should be really easy and fun. It's not for high schoolers. There's plenty of other options on the board for them. So what I want to encourage is there's lots of questions brought up tonight. So when you go over to your family and friends, to bring that discussion to them of what ignites them around science, if anything. What is it about science that brings them to life? What is it about discovery, curiosity, that's going to really drive us into the next generation? Because the thing I felt below all of this is that science does have a place here, and it is important for everyone. That's the agreement that I heard. I don't know if anyone disagrees with that. I hope not.
Well, Kishore and I talked about this, but he was asking me like what sort of got me into it and what keeps me going, and I was emphasizing that it's a social thing. Like when I saw those kids in my garage, and I realized that the most interesting thing was seeing how interested they were, and then working with that and seeing how me as a teacher and they as students were learning sort of together and in synergy or whatever you call it with each other. And so that's another reason why you should all come in, because that's the way to keep science. The only way I've kept science alive in my life is by being a teacher. I mean, I am absolutely sure if I hadn't happened into this luckily and gotten support at various points along the way, I would have never stayed with my curiosity in science. It's the kid. I'm riding the wave of the kids' energy is the way I feel about it. And every time I get down, they just kick me up there, and I'm riding, and I'm going on another surf ride, and it's that energy. And I think, in totally disinterested, I'm saying you come in and you get, you'll pick up some of that energy when you're there, and so that's how we're looking.
Well, I think that's a great wrapping up comment. Thank you for everyone coming tonight. You're welcome to say, oh, there's another comment.
I just want to find out the answer to our light experiments. Then we proved all the textbooks wrong and everything. I'd love to hear the answer.
That's all. You don't have to be that quick. Do you need me to hold it?
Yes. You've always wanted to be easel, didn't you?
Yeah, I have.
So, you can't see that at all? Oh. That's so sad. All right, so imagine that you have the filament over here, and then you have the images made over there. All the drawings that you have light coming off one direction off of the filament. And that's the problem with all of these. Light doesn't come off in one direction. Light goes in all directions. It goes this way and this way and that way. And some of the light goes there, and that light goes down to the appropriate other side. But that's not the only ray that hits the lens. That ray also hits the lens, and another ray off of here also hits the lens, and they bend so that they come together on the image. So there's an infinite number of rays that come off of the object that then hit the lens. If you block some of these rays by putting a card here, this ray can still get through to make the image.
And so that's the model. This is a hard model to draw. It's complicated looking. Like, it's already complicated, and I'm only drawing one point. And that's why the people in the book don't want to do it. That's a bad reason, don't you think? So this is the better model for how it's done, of how light gets to everywhere.
I made a comment. Does this also have, I don't want to get too technical, but has there got some quantum mechanics involved in the photons and everything?
Sure, but only in really unusual situations. In the basic, like, how is an image made, it's pretty much straight geometry.
There's nothing better than having the physics professor nod in total agreement with you. So I want to thank all of our presenters tonight. Dan from Mission Science Workshop. Zeke from the Jewish Community High School by the Bay. And of course Chris, who scared the shit out of me with that snake. And of course, Atlas Cafe. Always does a good job, but will never take any of the credit. So next month, E. coli, your friend in treating cancer. This isn't the E. coli from the Wendy's burger. This is the E. coli from the lab that will save us. Actually, I think this will be really interesting because beyond of all the engineering and the ethical questions that it raises, it also is just a fascinating story about a young scientist, which is not something you always get to see at times. And he's also willing to talk about the nature of becoming a professor at 32. Or 30, I think, is when he became a professor. Thank you so much. Check out the websites, and have a good night tonight. Continue the discussion at home.